Hello students, today I am going to explain highway materials, model 3, lecture number 2. Coming to highway materials, first one is subgrade, aggregate, bituminous materials. Under subgrade soil, desirable properties of subgrade soil, HRB classification of soil, determination of CBR of soil, determination of models of subgrade reaction of soil. Under aggregates, desirable properties and list of aggregates. Bituminous of materials. Under bituminous materials, explanation on bitumen, tar, emulsion and cutback, and list of test. Subgrade. Coming to the subgrade here, the top soil or subgrade is a layer of natural soil prepared to receive the stresses from the layers above. Here you can see the subgrade or existing soil. These are the different layers above the subgrade. It is essential that no time soil subgrade is overstressed. It should be compacted to the desirable density near the optimum moisture content. This is about subgrade soil. Then coming to the desirable properties of subgrade soil, first one stability, incompressibility, permanency of strength, minimum change in volume and stability under adverse condition of weather and groundwater, good drainage and ease of compactions. Coming to the soil classification system, here very important HRB or ASTO or revised PRA classifications. Coming to the Highway Research Board HRB classification, this is also called American Association of State Highway Officials as classification of revised published road administration soil classification system. Soils are divided into 7 groups from A1 to A7. In that A1, A2 and A3 soils are granular soils. Percentage fines 0.074 mmCu being less than 35%. So here very important thing is you should remember this percentage. If the fine is passing 0.074 mmCu is less than 35%, this comes under A1, A2, A3 groups. And coming to the A4, A5, A6 and A7, soils are fine grained or silt clay passing 0.074 mmCu being greater than 35%. If the percentage passing more than 35%, that comes under A4, A5, A6, A7 groups. So should remember these two things. If less than 35% and greater than 35%. If it is less than 35%, this comes under A1, A2, A3. That comes under granular soil. And if it more than 35%, it comes under A4, A5, A6, A7. That is fine grained or silt clay soil. Coming to the A1 group soils are well graded mixture of stone fragments, gravel, coarse sand, fine sand and non-plastic or slightly plastic soil binder. The soils of these groups are subdivided into 2 groups, A1A consisting of predominantly of stone fragment or gravel and A1B consisting of predominantly of coarse sand. Then A2 groups of soil include a wide range of granular soil based on a fine content. The soils of A2 are subdivided into groups A24, A25, A26 and A27. Then A3 groups soil consists mainly uniformly graded medium or fine sand similar to beach sand or desert blow sand. A4 group soils are generally slightly silty soil, non-plastic or moderately plastic in nature with the liquid limit and plasticity index value less than 40 and 10% respectively. So this is very important. The liquid limit is 40% and plasticity index is 10%. Then coming to the A5 groups, soils are also silty with the plasticity index is less than 10% but with the liquid limit values exceeding 40%. These includes highly plastic or compressible soil. And A26 group soils of plastic clay having high values of plasticity index exceeding 10% and low values of liquid limit below 40%. They have high volume change properties with the variation in moisture content. Then coming to the A7 group, soils are also clay soil as A6 soil but high values of both liquid limit and plasticity index. These soils have low predominantly and high volume change properties with the change in moisture content. I will explain A4, A5, A6, A7 group along with the graph at the end of this session. So here we can see that general descriptions and granular materials 35% or less passing 75 micronasive and silt clay materials more than 35%. So more than 35% comes under A4, A5, A6, A7 and less than 35% comes under A1, A3, A2, and there are some criteria to identify the HRB classifications. Coming to the group index of soil. Group index is a function of percentage material passing 0.074 mm liquid limit and plasticity index of soil is given by the equation group index equals 0.2a plus 0.005 AC plus 0.01 BD. A nothing but that portion of material passing 0.074 mm sieve greater than 35% and not exceeding 75%. It usually lies between 0 to 40%. B. That portions of material passing 0.074 mm sieve greater than 15% and not exceeding 35%. So again it lies between 0 to 40. Coming to C, that value of liquid limit is excess of 40% and less than 60. Usually the value is 0 to 20. D equals that the value of plasticity index greater than 10 and not more than 30. Usually is 0 to 20. So you should remember this, what is A, what is B, what is C, what is D, while solving the problem. According to this formula, the minimum possible values of group index is 0 and the maximum possible value is 20. When the value of soil fraction passing 0.074 mm sieve, liquid limit and plasticity index are respectively higher than 75, 60 and 35%. Higher the values of group index, poor is the soil as subgrade materials. So I told in the previous slide, I am going to explain what is A4, A5, A6, A7 in the graph, right? So here in the x-axis you can see here liquid limit and y-axis in the plasticity index. So this is the figure 9.1 liquid limit and plasticity index for non-asto soil groups. So here if the liquid limit is less than 40% and plasticity index is less than 10%, that comes under A4 group. Then liquid limit is greater than 40%, and plasticity index is less than 10%, that comes under A5. And again liquid limit is less than 40% and plasticity index greater than 10%, that comes under A6 group. And liquid limit is more than 40% and plasticity index is more than 10%, that comes under A7 group. Thank you.